Hello. In this video, we're going to briefly go over the two homework problems that I assigned from the book. Which book? A book. So here's a picture of the first one. Pen, come on, pen. Sorry about that. So if QC is less than KC, in which direction will a reaction proceed in order to reach equilibrium? And we know that Q equals the products over the reactants to a power. And we're saying Q is less than K, which is also the products over the reactants. And if Q is less than K, that means that, do I have a different type of, what does this do? Great. That this has to be less than this, if Q is less than K. So if we have a reaction, A plus B makes C plus D, in order for Q to equal K, the products are going to have to become greater to make this become bigger. So the reaction would have to shift towards the products, or shift towards the right. And once the product concentration actually equals the product concentration over the reactants, once that ratio is equal to this, then Q will equal K. That's how you answer that question. Here is the second homework problem, and I'm going to go over these step by step, A, B, and C. We know that the value of K is equal to 2.19 times 10 to the minus 10, and we're asked if these following concentrations will be at equilibrium, or how the reaction must proceed in order to achieve equilibrium. So let's look at each one separately. The first thing I do to solve this problem is I write down the expression of the equilibrium constant and what it is equal to, so I can be looking at that. That's the first thing I do. Then I look at the variables for the first one, A, and if I plug them into my expression for Q, and the way you set up Q is going to be the same way you set up K. Q is just whatever the concentrations are. K has to be equal to this amount. So I plug in my variables for the products and for the reactants for Q, and this is what I get, and then I divide the numerator by the denominator, and I get 10.92 times 10 to the minus 9, which is 1.092 times 10 to the minus 10, and that number is greater, wait a minute, what did I do wrong here? I moved my exponent the wrong way. This should be 10 to the minus 8th. And this value, which is Q, is greater than K, because this number is bigger than this to the negative 10th. And so the reactants must increase to make Q become smaller. This amount will have to become bigger. And so the reaction will shift left to make more reactants. You can look at B here. I plugged in the values for Q, just whatever the concentrations are, and I calculated Q. Of course, can you see this? And Q is equal to 0.55 times 10 to the negative 11, which is, let's rewrite it up here. This is Q, and this number is less than K. Oh, new pen needed. And so since Q is less than K, you're going to have to make the numerator bigger to make Q bigger so that it equals K. So the reaction for B is going to shift towards the products, or shift right. And this is C. Again, I plugged in the values for Q, because when you want to compare concentrations at any point in time, you compare the concentrations, that gives you Q, and then you compare that to K. And with these values, Q equals 2.19 times 10 to the minus 10, which was your equilibrium constant. It was 2.19 times 10 to the minus 10. So this situation is at equilibrium, and there is no change. Okay, in the next video, I'm going to review the lab a little bit.